Okay, good morning. Let's start now. Today, I will be talking about the software defined networking. What is SDN and what is SD-WAN and what is SD-LAN? These all we are going to discuss it today. I guess Zoom will allow me to extend this meeting for 1 hour or something. Let me see. I'm using some different login this time. Anyway, thanks for joining all the people. Good morning. And SDN is nothing but software defined networking. Software defined networking, why it is required, why this SDN has come up at all first in first place, and what is already the network which has been already lying in our hands, which we have constructed for the on-premises data center, and in the cloud, everywhere we've been doing that, and we are doing a lot of VPNs over there. Currently, I'm working from the home only, so it's a VPN. I guess I connected with the VPN connections only. So we have seen some site-to-site VPN, clientless VPNs, remote-to-site VPNs. So many already technologies are there already, right? So why do we look for this SDN? What is it going to give us the benefits for the SDN when we are going for a solution of the SDN? And who are all providing this SDN service? SDN services are provided by many vendors. We will be seeing the list of the people who are providing this SDN services to us. How do we go for this SDN connections? How do we subscribe to this SDN connections? How many months we are going to utilize it? How many years we will be using that? And what will be the differences between the normal WAN and the LAN connections to the software defined networking connections? And how does it going to differentiate between the traditional WANs and LANs to the new SDN networking? Networking has got a lot of, like long history for last 30, 40 years. Whenever there is a computers has been started, the networking has been started. So we were using some normal cabling like coaxial cables, structure cabling like which we use the UTP, STPs, fiber cablings. These all I was talking about nothing but the local area connections. When we go for the wide area network, in the sense we'll be using the lease lines, ISDN connections, satellite connections, and the fiber connections which are running between the two cities or between the countries. Or we will be using some of the cables, underwater cable also, like over the oceans, we will be taking the underwater cables. Like this network has been already been there because using these networks only we are connecting to the internet daily, and this meeting has also been hosted on the internet only, so everyone has been able to join that. So how does it going to differentiate the SDN from the normal network? And for to know about that, we just need to have some proper understanding of the local networks which we are already been doing. Local area network which we will be building it for our own within our building or within our campus, within our university campus or hospital campus, or the ID companies whichever they are doing it, like whatever the networks which we are managing currently now. So those networks are which been already been there as a local area networks, and they have got some kind of connections over all over the world. Like we will be connecting it through the wide area network on this. So wide area network has been connected through the lease lines, satellite connections, and fiber connections sometime, or maybe like through the underwater sea cables and all like that. We used to do that. So how does it going to differentiate that particular SDN which we are going to discuss it today? That's what the more important point. And many people are thinking that whether it is coming it as an SDN in the sense of should I know about the scripting, because people are hating the scripting nowadays, because without scripting you will not be able to survive in the market today. As of today, the trending which I'm telling that for the last 5 years, whenever there is a cloud has come into the market, cloud computing which been offered by AWS, Azure, Google and other things. So these all already been there. These are all providing like a lot of services to us, not freely, or freely in the sense like if you wanted to do some kind of R&D something like that, you can take it something free, but business proposals cannot run on the free tier or something. So what we need to do, we need to purchase that particular cloud service. Then we will be going for this. In the cloud service, we've been doing a lot of scripting and all. So people are having that mentality that that I should be doing a lot of scripting on SDN. No, not required at all. That's not about the scripting at all here. We are not going to discuss anything about scripting defined networking. This is not the scripting defined. This is software defined. Software defined in the sense the name itself is it is saying that software defined because there is no hardware equipment will be involved in designing, implementing, maintaining this software defined network. Software defined networking in the sense we will be creating the virtual switches, virtual routers, and virtual links between them. And they will be talking in between. We will be creating the virtual LAN. That concept has been already been there in the normal networking and all. But virtual switching, virtual LANs, it's called as a VX LAN, it is called as. So these are the things which we will be, I'm admitting another person, okay. So these are all the things which we are going to discuss it. So SDN is not about the scripting or something. If you know scripting, it's nice. That's a different issue. Sorry. But for to talk about the software defined networking in the sense, you don't require to know about anything about the scripting. But you should be knowing about a lot of basic fundamentals, basic contents of the network. How does it working? Without having a proper experience on the physical networking, which we currently working on, like through the lease lines or broadband connections, or through the wide area network connections, or through the LAN connections, and server and client connectivity, databases, softwares, and everything. We should be having at least some experience, at least 2 to 3 years, if you are working already in the network or something. Core networking, I would like to say either people who are supporting that or people who are designing it or people who are been to the extensive designing of the network for the ISPs. Like everyone can do the SDN, but there is a current trend is that the SDN should be known to all the network people. That is what required. And you may be asking that whether the software person should know about the SDN. Yeah, if they know the concept, it is nice, because people doesn't know even know about the SDN. What is SDN? They didn't know about. There is just still just a technical jargon for them. Software defined networking is not about the hardware. Software defined networking is about completely software. Completely software, we are not going to write any code for that. We will be configuring certain through the commands, we will be able to configure all these things. That's how we are going to do that. We will be creating the VXLANs, we will be creating the VPEPs, we will be creating the V managers, V controllers. Everything is coming as a V. V in the sense nothing but virtual. Completely virtual. Our world is itself is a virtual, because due to the corona we are all sitting in the home and we are meeting through the virtual only. So this is the possibility of the software defined networking. This is the right time I just need to discuss about this, because we are all sitting in virtual locations only and we are talking to each other. So I should say that we are talking on the virtual software defined networking. Software defined networking. Let me go to these slides one by one so that you will be easily understanding. And at the end of this, the meeting or session, I would like to show you something which I created a little bit of SDN. I can just say SD-WAN I created on GNS3. That is a virtual simulator which we can call. Through that, I'll be able to show some small practical on that, lab on that. Then we have SDNs which are created by the VMware, and other people are giving us free for to do the practicing in the internet itself. I'll show you that sites so that you will get some idea that how to work on SDN platform. Like many vendors are there. So little bit of one or two vendors I will be, some other people I will be like, some other vendors I will be introducing to you, which are very quite famous and they are doing already the good mark, a good share in the market for them. So I would like to I would like to exhibit those people to you so that you can able to understand that who are providing the solutions. Before going the solutions, what are the things you just need to have in hand? Means like a checklist you should have it, because when you are going for an SDN connections or something, they will be asking a lot of questions to you. So you should be able to answer those questions like whether you definitely require SDN or not. So that we will come to know when I go through the slides part of it. Okay, let me see the F5. Okay, software defined networking. Let me read out this. SDN technology is an approach to network management that enables dynamic, programmatically efficient network configuration in order to improve network performance and monitoring, making it more like cloud computing than traditional network management. Yeah, it's exactly like a cloud management only, because we are going to manage everything over the, which is not in our hand at all, which is not a physical, which is not in in our place, which is not on-prem. So that is going to be the software defined networking. So as usual, that we are working with the cloud computing already, AWS, Azure, and Microsoft Azure, and as well as the Google Cloud and all, we are working on that. The same way we will be working on software defined networking also. The physical separation of the network control plane from the forwarding plane, where a control plane controls several devices. There is a split between the control plane and forwarding plane. If people who are working on a networking for quite a long time will understand this forwarding plane and control plane. Forwarding plane is nothing but the packet forwarding it takes place. Control plane is nothing but like which path need to be chosen and where the packet has to be sent. That is being controlled, monitored, and executed by the control plane only. So forwarding is just like whenever there is a command comes in, it will just forward it to that particular port or something. So this physical separation of the network control plane from the forwarding plane, where control plane controls the several devices. Next, architecture decouples the network control and forwarding functions, enabling the network control to become directly programmable and the underlying infrastructure to be abstracted for applications and network devices. So this is the best thing whichever it is available on the SDN, because conventional networking devices are having the ASICs. ASICs means application specific integrated circuit. That has been a concealed information which we don't know what is actually running on in between that. But we will be getting the output of it. When I'm sending a packet from one port, the other port will be definitely receiving it. How does it forwarding? What is the mechanism is being designed inside that ASIC chip, which we don't know. I like that Cisco has made its own protocols, EAGRP protocol, which we may be knowing only the skeleton of it. We don't know how does it working inside. That has been completely thrashed. What they are doing it, control and forwarding functions enabling the network control to become directly programmable. Directly programmable in the sense we can do the programming, we can create all these things. Its complete control is in the user's hand, not on the company's hand, and the underlying infrastructure to be abstracted for applications and network services. What the thing is done, SDN will be deciding every other path determinations and other things. Only the physical devices will execute the operations. So the control is in user's hand now. That is the best part in the software defined networking, where there is no room for any development on Cisco devices or Juniper devices or Brocade devices, whatever the devices which is currently available for the network devices, which will not be able to do any programming stuff, because those programs are already done, embedded, and it has been sold and it has been sold to us, which we will not be able to modify anything on that, which we don't have any control on that. And those are all coming under the proprietary trademark like that. If you try to break it out, you will be into ending up in jail. That is a problem. So here, software defined networking, which is doing that, there is the best part is doing that, the control is coming into our hand. And whatever the control which we are doing it, according to the control specifications, the physical devices will be operating. You can even add the Cisco devices, you can even add the Juniper devices. According to our control, they will be working on. We are not working under the control of Cisco or Juniper or something. So that is the best part, but you should be having a proper understanding of the conventional and traditional network, how does it working, so that you can able to understand the SDN. Because SDN is a complex, controlling options are very much complex. And the complex which I am talking about, because of that, there are many vendors are there in the market. Every vendor has got his own way of, defining it through the software. We should be learning all these things as per the company which is going for and which kind of the support provider or something like that, from where they are taking it, like you just need to read them all the documents properly. Then only you will be able to do the SDN controlling and management and other things. There is no universal technology as such for SDN. Everybody has got their own technology. Every company which is producing their own technology and they're selling it to us. But still, the control is going to be within us. We will be able to control it everything, but we require some certain training. Definitely, a training is required for you to manage the SDN. It's not easy. Like you are just taking one Cisco switch and you are configuring some port numbers and you are giving access a trunk port or something, connecting the cable, it start working. Not that way it is going to work, because why it is working in the sense minimal thing only we are doing it. End user configurations only we are doing it. We are not defining the packet forwarding or path forwarding or MAC address controls or MAC address learnings. Nothing we are doing it. But those all things we will be doing it in the software defined network. That is the best uh, the difference between the SDN and traditional LANs. Next, SDN architecture. Three layers in SDN architecture are application layer, control layer, infrastructure layer. Application layers, the application and services running on the network. That is an application layer. Second, control layer. That control layer is nothing but SDN controllers resides here. That is the brain of the network. Then the infrastructure layer. Infrastructure layer, normal routers and switches, we can connect it to that. That SDN controller, which is brain of the network, which we can control. That is what the freedom which we got from SDN. Earlier, in the normal traditional networks, all three things are controlled by the company which is selling the equipment. That is not there now. What is been there now is like application and control is in our hand. Only the infrastructure is like it's not so freedom because we are going to buy some of the equipments from the market only, so we can connect to that. But the control is still in our hand. We will be able to control those switches and SDN ready switches, SDN ready routers which are coming up. Those all can be programmed by us. Programmed in the sense what, like how the packet forwarding has to be done, how the path finding has to be done, which path need to be chosen, like that. So those all things which we can able to control it. So to communicate between these layers, SDN uses northbound and southbound application programming interface APIs, where the northbound API communicates between the infrastructure and control layers, and the southbound API communicates between the application and control layers. We will be seeing something explanation about what is northbound and what is southbound. So there is a API is nothing but application programming interface. So again, you will be able to ask me like whether should I know the scripting for to know this one? No, not required. Through some menu selections or by some commands which we will be able to do this APIs. No worries. So let's see what is northbound API and what is southbound API. This is just a description given. Infrastructure and control layer, northbound API, and the communication between application control layers, southbound API. Here you can just see application layer. Business applications are in the top. APIs are talking between, and there is a control layer. SDN control software is sitting. Network services are running here. That will be talking to the control plane interface. Like an open flow is one of the protocol. Through that, we will be able to control the entire infrastructure layer here. Network device will be sitting on infrastructure layer. Application, control, infrastructure layers are kept separate in SDN and they communicate through the APIs. Let me go to the next one. Northbound API applications talk to the control layer via the northbound APIs and they tell the layer what resources the applications need and their destination. The control layer orchestrates how the applications are given to the resources available in the network. Northbound APIs are often using RESTful APIs. Orchestration is automated and not manually configured, like that. So northbound APIs are communicating between the control layer and application layer. Southbound APIs. SDN controller communicates with the network infrastructure. Network infrastructure is nothing but traditional switches and routers through the southbound APIs. In real time, the controller can change how the routers and switches are moving data. The data no longer relies on the devices and routing tables to determine where the data is going. Instead, controller's intelligence makes informed decisions that optimize the data path. This is the best thing which is being offered by the SDN. What the devices which we are going to purchase it from the market, which are all SDN ready, only those devices we can activate. Normal conventional which are already we've been using 1900, 2900 and all, it will not work. Switches, Cisco switches, I'm telling. So we need to take the switches which are programmable, which are controllable by the SDN. Those switches only we will need to purchase. Then we can activate them under the SDN architecture. So northbound APIs and southbound APIs, this we see in this, and we will be talking about the controllers. SDN controller is a software that provides a centralized view of and the control over the entire network. Network admins use the controller to govern how the underlying infrastructure forwarding plane should handle the traffic. Entire control is in our hand. The control is also used to enforce policies and dictate network behavior. Network admins establish policies that are uniformly applied to multiple nodes in the network. And the network policies are the rules that are applied to traffic that determines what level of access it has to the network and how much resources it is allowed and what priority is been assigned. And you can just see this. This is all nothing new, which we've been already been doing that, writing an access list and configuring the routing protocol and configuring the spanning tree or something like that. But those are all proprietary things which we are running the commands only. But the SDN controllers, we can configure everything by our own designs. That is more important. Freedom is given to us. Having a centralized view of network and the policies in place makes the simpler management of the network, and that is more uniform and consistent. So this is about the SDN controllers. SDN controllers are also available in the market. Like Open Daylight has been there. It's a new name for you. Open Daylight is providing a lot of controllers for us. We can buy. We can. It's actually not no need to buy it. It's a free. Open Daylight, we can download it and we can start controlling all these things by arranging the equipments which are able to controlled by us, like that. Controllable. Those devices we can purchase and we can do. Next. What are the benefits of an SDN? Direct programmability, centralized management, reduced capex, reduced OPEX, agility and flexibility. Let's see one by one. Direct programmability. SDN network policy is directly programmable because the control functions are decoupled from forwarding functions, which enables the network to be programmatically configured by proprietary or open source automation tools, including OpenStack, Puppet, Salt, Ansible, and Chef. You see that? These are all the direct programmability is possible. Ansible and everything is an open. Everything is an open source actually. Puppet, Salt, Chef, Ansible. Ansible is an open source. We use it for the a lot of network automation things and all. Deployment we will be using this Ansible. Okay. Okay. Then centralized management. Network intelligence is logically centralized in SDN controller software that maintains a global view of the network, which appears to be applications and SDN network policy engines as a single logical switch. Centralized management is possible through the GUI. We can able to configure it so easily. Then reduce the capex. Capex in the sense capital expenses. SDN potentially limits the need of purchase purpose built ASIC based networking hardware and instead support pay as you grow models. It is not pay as you go, it is a pay as you grow models with its scaling capabilities. Most switches on the market support SDN capabilities, whether it is in data center or another network. If the infrastructure contains switches with SDN capabilities, they simply need to have option activated. Massive truck rule is not needed to rip and replace the infrastructure. Means if you are having something switches which are ready to get accommodated under the SDN network in the sense, we don't need to buy anything new. That is what. SDN potentially limits the need for purchasing the purpose built, means ASIC based networking hardware. We don't require it. ASIC means application specific integrated circuit, which is being used in all the internet switches which we are using currently. That ASIC is a proprietary programmer. We will not be able to see that it is a one-time programmer. And it has been programmed by the company which is selling the equipment only. We don't have any control about that. What mechanism is being used inside the ASIC is not known. That's why. Reduce the capex. When we are going to buy some Cisco switches like 10 to thousands of switches, something like that, we may have to build like billions of dollars need to be spent for it. But that has been completely removed. We can take any normal switch and we can make things to work for us by using the SDN controllers. So that is what we discussed. And the next is the continuing reduced OPEX, operational expenses. Capital expenses, you are buying and things, operational expenses, which are currently going to get maintained. The ability to automate the updates to the network software means there is no need to rip and replace the whole infrastructure when business needs or network demands necessitate a change. Additionally, policies can be uniformly spread network wide, reducing the chance for human error when updating the network. Automation takes over the monotonous tasks from network admins and operators, which reduces the overall network management time. Operational expenses are very much reduced because when you are buying multiple vendor equipments, for example, you are buying a Dell switch, Cisco routers, Juniper firewalls, right? FI load balancers, everything you should require some commands for that. Every other commands are completely different. They are not same because they would like to put some like frills in their own operating system or something like that. We will not be able to control it properly unless and until we are trained properly on that equipment only. So here that it is coming as an uniformly. That's what policies can be uniformly spread network wide when we are doing the maintenance of this. That is what they are discussing. So the time is reduced, productivity is increased. Uniformly, you can run the commands to understand that. So everything is coming like an open source for us. Okay. So then agility and flexibility, SDN can help organizations rapidly deploy new applications, services, infrastructure to quickly meet changing business goals and objectives. Because whenever something new is created, a simple update deploys enterprise and deploys it network wide. Yeah, that's what. Whenever we are making some changes, we have some policies. The policies can be applied across the switches, across the network vendors. It's possible. That's why it's very easy for us to maintain. We don't require any much user force, much network engineers force for to configure each and everything, one by one or something. So we may have to hire the persons who are FA trained, who are what is AWS trained, who are Google Cloud trained, or the person who trained on Juniper and Cisco something not required. If the person knows about the SDN, it's enough for us because I don't require any single resource for to maintain single resources for someone. I don't require any FA engineer. I don't require any Cisco engineer, Juniper engineer like that. So one engineer can do all. That is what been expected. But in Indian environment, actually the person has to learn everything. Juniper certification required, Cisco certification required, FA certification required. But that is not required now because if he knows that, he doesn't need to go for any other certification because he can do anything. One program fits all, one size fits all, like that. So that's what the benefit of SDN. Next, SDN challenges. What all maybe like whenever we are talking about the benefits, there will be some challenges as well as the drawbacks also. What are the drawbacks of it? SDN is not without its downsides. As with everything in the IT industry, there are security issues, scaling problems, lack of widespread industry cooperation. That's what people doesn't like it. If they are already standardized on certain equipment, they don't want to come out of it because it's very easy for them to maintain it. Uh, as per from the because I have quite long experience on the support side, we don't want to upgrade the things and all. We never upgrade it because whenever you are upgrading it, there will be a lot of problems will come. Because when we are not upgrading it, we know that what are the problems are going to come up, how to solve it. Everyone has got like completely by hearted. This is the problem, this is the solution. So now SDN is completely a new technology. People doesn't like to introduce it because when you're introducing, standardizing and things getting normal, it may take 1 or 2 years or long. So until then, there will be a lot of like we just need to fight and there will be a lot of blood need to be teared. That's a problem. So we don't like the SDN to come up. That is also like there is a cooperation is not there. Widespread industry cooperation is not at all there. So we are already running that we have only 10 sites I'm conducting with my own routers and I'm, like I just maintain that I have some own IP address scheme. Why do I want to go for a cloud like, some other thing? People are still having the mentality whether to go for a cloud or not. Now the SDN has come. That every day there is some new things are coming up. People doesn't want to get adapted to it because there is a lot of training is required, patience is required, and a lot of wear and tear is required and a lot of like midnight hours just need to spend on this to understand all the concepts and other things. So people doesn't like it. This is the challenges. Security risks of centralized management. While this makes networking easier, it also a security risk. Centralized management is a single point of attack, and if it goes down, the whole network is affected. Beautiful. So we just need to maintain more security, firewall configurations, policies making it. That is required. Next, controller bottleneck. When there is only a single instance of an SD controller, it can become a bottleneck for the network with a large amount of traffic, routers and switches. There is simply too much to communicate with one instance of the controller. So we cannot just go with just one controller. We may have to make some multiple controllers. When we are multiple controllers, they need to get synchronized. When they are getting synchronized, there should be a database need to be made. When there is a database is need to be made, then again we just need to maintain with the engineers only. So there is a lot of like ifs and buts are still there. And every other technology there is ifs and buts are there, but still I'm telling. No universally accepted standard for northbound. Without a universally accepted standard of northbound, vendors and open source organizations are making dissimilar APIs for their SDN control. This was I was telling you. SDN providers are too many. You will be seeing the list around 10 to 15 I listed already. Everybody is making their own APIs. We can still program it. That is not an issue at all. But every other way that people are making it their controller to work, we just need to learn those skills. So there is no similar kind of an API making in between the vendors. That is not being completely cooperated. They are not ready for that also. Again, that will go to the proprietary way only. That is a problem. This makes application development difficult because in order to interoperate with the different controllers, the developer has to make multiple versions of application. That's what I was telling you. When there is different application is there, if you written a program, if you written a set of policies, if you written an API for a certain application, in the sense that will not be universal. It cannot work with every other applications. We need to write a different APIs for different applications as well. So these are all the challenges. This also will get overcome by the years to come because they will be sitting down and they will be starting writing something on the universal APIs and all. Otherwise, you can just do that. If you're a programmer, you can write some universal API to manage every other application and controls. That's up to you. Use cases where all we are using it, like it's just an example only. There are so many are there. I given only three. Automation enables the DevOps approach, including automated testing and deployment changes to applications and virtualized portions of the network. Smart buildings can also make advantage of SDN to handle the wireless network that connects all devices within the building. Virtualization principles on SDN introduced to the networking world also be used in vehicle to everything, that is a V2X. Communication for autonomous driving. SDN software normally covers a single data center. However, it can extend over entire campus. By using SDN technology, a campus can simply the wireless and wired network connections, whether it's a Wi-Fi or Ethernet, centrally manage them and automate the services. Like where all we can use the SDN use cases like that. Okay, the next one is like SDN relationship with the SD-WAN. What is SDN and what is SD-WAN? SD-WAN is different, SDN is different. SDN is an extension. SD-WAN is an extension of SD. Means software defined wide area network is an extension of SDN. SDN includes SD-LAN also, SD-WAN also. There is a difference. SD-WAN applies SDN to networking connections that cover a wide geographical area. According to IEEE, this technology allows enterprises to connect all their networks within their system across a wide geographical area, being restrained by the distance between nodes. For instance, all the branch office network and data centers within a national enterprise with branches in every state can be connected via the SD-WAN and managed by single central controller. Another perk to SD-WAN is that provides end-to-end encryption across the network, thus increases the security. This is actually in a question actually, how much security we can exercise on. That is also. Then SD-WAN is also applicable to large local area network LAN to create SD branch deployment for a single office or location. This can be used for networks and data centers that need to be kept on premises at a branch for security, regulatory, or logistical reasons. SD branch still offers the flexibility and scalability of the SD-WAN. So what is SD-WAN? SD-WAN is nothing but like is an extension of SDN. Extension of SDN in the sense software defined network, there is one portion is called as an SD-WAN. So whatever we are applying it, actually it is a concept behind the SDN only, and we will be constructing that SD-WAN on top of it, and we will be using some controllers on that. And with the controllers, the applications can be controlled and physical devices can be controlled. And let us go to the SD-WAN things mainly on this, because this session I try to make it out for SD-WAN connections only. We will see for SD-WAN. SD-WAN is nothing but software defined wide area network. What is SD-WAN? SD-WAN is a combination of technologies designed to offer a similar approach to the WAN. It has been driven largely by the decreasing cost of bandwidth and increase in cloud applications that reside outside of the legacy data center. This is the first point. Second, it can be deployed over existing WAN connections, whether they are internet, DIA means direct internet access, broadband, LTE, long-term evolution. So we are talking about 4G and 5G and other things, or private. MPLS and private lines, multiple uh, protocol label switching, multi-protocol label switching. Like that, we can just do that. And in order to create a secure, private, and full meshed network, and it offers a simplified management, quicker turnup, better applications performance, improved resiliency, and cost savings when compared to the traditional approaches. SD-WAN will dynamically steer the traffic to the best available link. And if all the available links show any transmission issues, it will immediately apply remediation for jitter and packet loss based on the policies to ensure the performance of the high priority applications. Whatever we are doing it on the WAN, we can exactly the same thing can be applied to the SD-WAN only. Only the change is that the controller is going to control everything. So it is an SD-WAN is nothing but a WAN only. WAN we are creating it over the internet access, broadband, LTE, and MPLS and private lines. Same thing we can do it with the SD-WAN also. So that there are some terminologies you just need to understand the SD-WAN operations. Overlay versus underlay. What is overlay and what is underlay? These two terms are very important when we are discussing about the SD-WAN connections or SDN connections, you can just say. Physical topology, you can just see in the down. In the physical topology, there is a BGP connection, is the routers are connected, and there is a private network is in the through the private network, and the like campus network nodes are there. They are all connected. This physical topology is called as underlay network. Which is physical is called as an underlay, which is lying under. That is an underlay. Overlay is nothing but the virtually which has been getting created. See that vPort, virtual routers, and virtual tenant router B, virtual switch, and virtual ports which are connecting on this. This is like a given in a dotted line because everything is virtual. Here you just see that all the straight lines are there because it is connecting to the physical lines. So overlay versus underlay. We will see the explanations about the overlay and underlay in the next slides. Underlay network. Underlay networks are so-called physical networks where traditional protocols are working. Underlay network is a physical infrastructure above which overlay network is being built. It is an underlying network responsible for delivery of packets across the network. The underlay network is described by physical devices and can be switches and routers in the network. All network components of the underlay must determine IP connectivity via use of routing protocol. These all we already know that. That's why I'm just reading it. Underlay network. The protocol used to the underlay devices are like OSPF, ISCS, BGP, and other protocols. For underlay network, there is a setup of a well-designed layer 3 foundation, inclusive of campus edge switches, which we are already working on, some catalyst switches and other switches. Scalability, performance, and high availability of the network. So underlay protocols are BGP, OSPF, ISIS, and EAGR. This we already know that because we already been working on daily basis. Like daily food comes from this underlay network management only for us. So we know everything about that. But we are going to discuss about some of the points on the underlay. Underlay network traffic flow. The traffic flow transmits the packets which traverse over the network devices like routers and switches. Deployment time. Less scalable and time consuming activity to set up a new service and functions. Definitely, if you like to construct a data center, how long will it take? It depends on the location which you are making it. The procurement which is goes for a devices, physical devices, it should reach the location first of all. We just need to transport it to that particular location and building it with the engineers, doing all the cablings, connectivities, and remote end connectivities, configurations of all the devices. Uh, that is called as like time consuming activity. Packet control is hardware oriented, definitely. Definitely it is a hardware oriented. Packet encapsulation and overhead, packet delivery and reliability access occurs in layer 3 and layer 4 and layer 2, something like that. Say. Multipath forwarding, less scalable options of multipath forwarding. In fact, using multiple paths can have associated overhead and complexity. Definitely, we are going to configure a lot of protocols on this. Every protocol will be learning all the path and everything. It will be keeping it in a table called topology or database or something like that. It has to maintain everything. That requires a lot of memory as well as CPU also. And multipath tenancy, NAT or VRF based segregation required, which may be a facing challenge in bigger environment. How many VRF will be creating? Virtual routing and forwarding. In MPLS network, we'll be creating the VRF. VRF, I used to create it like, near about 10 to 50,000 VRF you need to create to segregate the customers. That is very tedious and There is a lot of human, what do you say, human effort is required for that. And the change management has to come, that proper management is working on, and the level one people has to go and troubleshoot and all these things, many things. Also scalability, less scalable due to the technology limitations. Definitely, if you like to have some more ports, you just need to buy another switch. You cannot add it. In virtual, we will be able to add many ports as well. Okay. Packet delivery, responsible for delivery of packets. Okay, these are all the one thing, that because everything has to hit the physical, so packet delivery will be maintained by this. Protocols, we know the protocols, EIGRP, OSPF, BGP, and everything we've seen. And in the switching, we just see switching protocol, VLAN routing, and spanning tree. So many other things. This is the underlay network which we are currently working on. The next, overlay network. Overlay network is formed on top of underlay in direction to construct a virtualized network. The data plane traffic and control plane signaling is controlled within each virtualized network, encapsulating user traffic in overlay networks using IP packets that are sourced. How the overlay network has been formed in a descriptive way, it's been discussed. Overlay networking is a method of using software to create layers of network abstraction that can be used to run multiple separate, discrete, virtualized network layers on top of physical network, often providing new applications or security benefits. Overlay networking is not so easier. You just need to understand a lot of logical things. So that requires a proper, basic, fundamental understanding of the underlay network. Then only you will be able to develop yourself to get into the overlay. Overlay is very complex. It is not so easy to understand. When it has been implemented in a large scale, it will be a tedious task for an engineer to understand the entire network. It may take months and months for him to understand this, what is actually going on. So it's not so easy. I'm not saying that I'm an engineer. I can just say only the truth. Okay. Overlay network is a virtual network which is routed on top of the underlay network infrastructure. Routing decisions would takes place with the help of software. Software is controlling everything, not the hardware. Overlay protocols has been discussed here. VXLAN, NVGRE, GRE, OTV. O means like open, you can just take it as open transfer, transport, like the virtualization, multiple protocols, and whether it comes in. MVPN we can create, new generation, something like that goes. These are all the overlay networking protocol. We are seeing that in the next coming slides. Traffic flow, how the traffic flow is being determined by the overlay network, transmits the packet only along with the virtual links with the overlay nodes. They can talk within them only, they will not talk outside. Deployment time, ability to rapidly and incrementally deploy new functions through edge centric innovations, very faster. We can create 16 million VXLANs, it's possible, where we will be creating in the physical switches only 4096. Normal VLAN we can create only 4096. 4K is where 16 million is where you can this thing. Packet control is completely software oriented. Packet encapsulation and overhead needs to encapsulate the packet across the source and destination, hence incurs additional overhead. That's still small problems are there. Multipath forwarding, support for multipath forwarding within a virtual network. Managing multi-tenancy, ability to manage overlapping IP addresses between the multiple tenants. It's a very good feature which is on overlay network. Scalability, designed to provide more scalability than underlay network. That's what I was telling you. Like scalability means in normal switching we can create only 4096. That depends on again the hardware. Every switch will not support 4096, 1024, 2048, something like that. But maximum which we can do on a Catalyst 6000 or something, we can create only 4096. But you see, in VXLAN in the overlay network, we can create 16 million VLANs. VLAN is nothing but VXLAN. VXLAN is nothing but VLAN only. So packet delivery offloaded from delivery of the packets. So that has to hit the physical network. That's what they're discussing. Next, protocols. Virtual extensible LAN, that is called as VXLAN. Network virtualization using generic encapsulation, NVGRE. Stateless transport tunneling, SST. Generic routing encapsulation, GRE. We are already doing this. GRE tunnels are everywhere. That is again overlay. Actually, you can just call it as like a overlay. IP multicast and network virtualization overlay 3, that is NVO3. These are all the protocols are used in overlay network. So we seen underlay network and overlay network. Next we can go to asking some questions about that. Isn't SD-WAN really an SDN? Can I just say that SDN can be replaced by SD-WAN, the word? So not that way. Like software-defined networking is an architecture. Okay, whereas SD-WAN is a technology that can be purchased and built on foundational concepts of the SDN. SDN lies behind like a framework, but SD-WAN will be built by the vendors again. Again, the vendors. Okay, we have to buy them because we cannot create on our own. We can do it, but we just need to have some equipments for that and good programmers required so that we can do the open source kind of controllers we can configure with the open delete and other things. It provides a segregation of management, control, data planes, and better scaling and reliability by making the backup and failover for each plane easier. This prevents a failure in one service plan from affecting the rest of the services. It scales design using cloud hosted gateways for traffic steering to the cloud or to the data center. Cloud based management allows the ubiquitous access across all device types for easier management. So it's like a more of what do you say characteristics of the SDN, and it is a comparing things to the SDN. SDN is a concept or terminology or technology, you can just say, but SD-WAN is going to be an architecture. Like SD-WAN is a technology, you can just say. SD-WAN is based on the concepts of SDN. So let us go to the next slide. Benefits of SD-WAN: network agility, ease of deployment, central management and control, data segmentation, cost reduction. Every manager will be looking for this cost reduction only. All the PMP guys will be looking for only how to reduce the cost. Okay, network agility, because SD-WAN is a cloud delivered and software based. It allows for quick adaptation of the changing needs, including adding access to the cloud-based services, standing up new branches or remote offices, and a dynamic steering for all traffic optimized through application data delivery. Just like that, they'll just play, take it like ease of deployment. SD-WAN allows various deployment options of the edge device, including dedicated hardware, virtualized applications, appliance, hybrid solution, cloud, software, and hardware. In each instance, the component connects to a central orchestrator, which, when brought online, the configurations are pushed from the central orchestrator to the edge device. There is no need of specialized technician or to facilitate the installation, which saves time and money. Means you don't require an engineer to be sitting on every office to maintain the SD-WAN. That's what. Centralized place itself is enough. You just need to send the equipment and ask them to connect it. That's it. Once they switch on, we can pull it on there, then we can push all the controls over there. All the policies can be applied on this. It's like we are logging into the VPN like that. And centralized management and control, centrally located orchestrated monitors all network connectivity activity, alerts when there are problems, enables a remote remediation of issues. In addition, it delivers real-time analytics and reporting that can be used for performance monitoring and troubleshooting. Everything is central. Data segmentation. SD-WAN controller used to create virtual network segments to isolate data. Segmentation also allows overlapping IP addresses, which makes it easy for incorporate multiple networks into the system. This we are already doing it through the MPLS. Nothing new. Only thing is that the controller has gone open sourced or it is programmable. That is the only difference between the one more person is joining. Okay. Last point is cost reduction. Augmenting the existing infrastructure such as MPLS and lease lines with a broadband LTE and other connection types to increase agility and reduce the cost of bandwidth. Reducing problems identification and associated remediation costs. Central management and controller network activity eliminates need to send out trained technician to assess the issues and repair them. That's what you don't require an engineer, like on-site engineer is not required, or you don't require any field engineer also. Means he has to go and do some troubleshooting and all, not required. Allowing pay as you go options, subscription models are there that defray the high upfront investment costs and ongoing maintenance and upgrading fees. You don't need to purchase anything at all. No equipment purchase is required. When you're buying an equipment purchase, in the sense, you just need to work out whether the 7 years only will be the end of life will be there, then you'll have to go for an upgrade, then you have to go for patch upgrades and other things. Those are all not there. As end user point of view, nothing you need to purchase it. Zero touch provisioning allows the quick branch deployments and the time and accessibility as all the deployment functions are managed from the central ID home office. Means that is what zero touch provisioning is like. You connect the equipment, you ask them to connect the cable, switch it on. After a minute or something, I can push all the configuration from the central management. That's it. Their their particular branch office network is on the SD. That's it. So simple. That is called as a zero touch provisioning. Eliminating the need to deploy application specific hardware or software at each branch location, as the SD-WAN edge devices can host virtual services and a direct access to the cloud-based services. So these are all the under the cost reduction. We can talk about that. What are the benefits? The benefits are like network agility, ease of deployment, control management and control. Sorry, central management and control. Data segmentation is the cost reduction is also there. So it's just a comparison. Now we are talking about traditional WANs and SD-WAN, which are already been discussed a little bit, but we can just see the points on that. Traditional WANs where the majority branch office traffic flows within an enterprise intranet boundary and have been designed using multi-protocol level system for connectivity. However, new cloud applications such as Microsoft Office 365, Salesforce.com, and public cloud services such as AWS, Azure are changing the traffic patterns. It is not only the branch office connectivity; it goes through the whole all over the internet itself. So there are some changes are happening on WAN itself. Today, the majority of enterprise traffic flows to public clouds and the internet. This change creates a new requirements of security, application performance, cloud connectivity, WAN management, and operations. SD-WAN is a cloud-based delivered overlay WAN architecture connecting branches to the data centers and multi-cloud environments through a single fabric. Single fabric. One connection is enough for them. Whether they would like to go to their branch office, or they would like to go to the internet, or they would like to go to the like SD-WAN structure, something like SD-WAN structure is public cloud they can go for. Software as a service, infrastructure as a service, platform as a service connections, and offers integrated security either on premises or in the cloud. Anywhere, the one connection is enough for them to getting connected to anything they want. They want to surf in the internet, they can do. If they would like to go to the public cloud operation, they can do. Or they would like to have the branch office connectivity, they can do. Or they can go to the central office connectivity, they can do. So one connection makes all. So that is possible through the SD-WAN. That is what the advantage of it. Traditional SDN, traditional WAN, expensive bandwidth, unpredictable application performance, data center dependency, complex infrastructure. Complex infrastructure in the sense multiple vendor devices are loaded. Vendor devices are located. And again, a data center is required for you to co-locate your own servers or something. And expensive bandwidth, you just need to pay a lot of money for bandwidth as well. Either MPLS connection or failover connections you'll have to go for, ISDN connections you have to take, or satellite connections you'll go for. Unpredictable application performance. So it depends on the multiple links and connections, depend on the multiple resources we just need to talk. Application performance is not so good. SD-WAN, what is SD-WAN is offering? Virtual WAN, cloud optimized, pay as you grow model, simplified branch office services. These are all given. Deliver a network overlay with multiple links from different service providers to form a unified pool of bandwidth. Cloud optimized. We can even connect to the cloud by using just one SD-WAN connection. Pay as you grow model. Whichever the options which you are going to choose it out, accordingly you will be paying it. Not for like a stipulated fixed charge, nothing as such. If you're not using it for a month or something, no charges. And simplified branch services. That is like customer premises equipment, something has been done, which is in the cloud or something. So SD-WAN has got so many so many advantages compared to the disadvantages, I can say. So people are now moving even when you require it or not. Okay, when you are requiring it or not, SD-WAN connections are still there. And people are already talking about that and they have started moving to the SD-WAN connections as well. So now we are going to see how many vendors are there in the market for to provide the SD-WAN connections to us. You can just read it in my screen. The entire screen is occupied. Cisco, VMware, Silver Peak, FlexiWAN, HPE, CloudGenix, Versa Network, Cybera, Talari, Citrix, FortiGate, Arcaya Network, CenturyLink, Catacloud, open delete. This many providers, I guess I must have missed other people as well. But on this, actually, been very much discussed about this only when we are going for SD-WAN solutions or something. Only these are all being suggested from some of the internet links or some of the customers which they are discussing about this only. So, who is number one? There is no number one, number two. Who sold the multiple applications? I can just say Velo Cloud that is offered by the VMware. Second is coming like a Cisco. Okay. Third is coming like Silver Peak. Fourth is a CloudGenix that has been offered by Palo Alto. And Versa has also been there. Talari has been given by Oracle. Oracle is providing the Talari connections. And the Silver Peak, one good choice is that the Silver Peak has been purchased by HP. Hewlett Packard has purchased the Silver Peak. Like there are a lot of buying and selling will be there. But anyway, our connection is like our concern is like how to create our own SD-WAN connections. Cisco SD-WAN is called as Viptela. Actually, the company called Viptela was there earlier. Viptela has been purchased by Cisco and they made it like a Cisco SD-WAN. They named after. And Meraki was also one of the vendor who was doing some security activities and other things. They purchased the Meraki and they made it like a Cisco Meraki. And VMware is the one guy who has made this concept of SDN, SD-WAN connections and all. They made their own cloud called Velo Cloud. Velo Cloud is nothing but SD-WAN solutions. And VMware NSX also you can do that. And Silver Peak, HP, FlexiWAN, so many things are there. We will just see one by one what are the options, what are the equipments they use, how do they construct, which one is best, which is not so good, how much spend we are going to do that, how much we are going to spend on this. Like that we just see that. Cisco Meraki first, let me start with the Cisco Viptela and Meraki. Cisco SD-WAN is being purchased by, Viptela has purchased by Cisco and they started selling a solution called Cisco SD-WAN. Centrally managed, orchestrated, operated solution with a cloud-based Cisco vManage GUI management and provisioning platform, vSmart controller, vBond orchestration layer at the heart of the solution. vSmart controllers are the centralized brain of the solution. They implement policies and connectivity between SD-WAN branches. Centralized policy engine in the Cisco vSmart controllers provide policy constructs to manipulate routing information, access control, segmentation, extranets, and service chaining. Again, the controller is going to take care of everything. vManage. Cisco's GUI-based decentralized management and provisioning platform provides the ability to manage all aspects of the WAN, from provisioning, monitoring, and upgrading the routers to maintaining applications visibility and troubleshooting the WAN. vBond, sorry, vBond Orchestrator is a software software module that authenticates the vSmart controllers and vEdge routers in the overlay network and coordinates the connectivity between them. It must be having a public IP address that all Cisco vEdge devices in the network can connect it. So this is about the Cisco SD-WAN Viptela connections. It's continuing. What all the physical devices which are supported, what all the virtual devices are supported, what all the public cloud is been supported by the Viptela. That's been listed here. Branch office and regional data center hub sites can be deployed and connected either virtual or physical secure routers. Physical branch office, we can use Cisco IOS XC routers and Viptela OS based devices. And the branch can also use 8300 H series edge platforms and Cisco 1000, 1100 or 4000 series ISRs. Then branch, regional hub and data centers can support this 8500 series edge platforms and Cisco ASR. It's been already been there. And it's called as an aggregation services router. Either if you are using the physical devices, you can go with this. If you are using the virtual 5000 series enterprise network computer system, ENCS, and integrated services virtual router, ASRV, that's an appliance based network hub, co-location facility, and data center. Cloud services uses platform of 5000 and CSR like 1000 B series. With this, we can do the virtual connection of Viptela. In the public cloud, IaaS means infrastructure as a service. If you'd like to go for it, all these three are supporting this Viptela. It's been supported by the Viptela. So we can go with this SD-WAN on Cisco. Then Meraki is also there. We will see that next. Viptela, it's providing you the security capabilities, include an application-aware enterprise firewall, intrusion prevention, DNS layer enforcement, Cisco Umbrella. It's a new technology they brought it, and URL filtering is also been there. Every other firewall will be supporting this. Cisco SD-WAN reduces the complexity of by having a single management interface we manage for both network and security. You can just see a list of things platforms are discussed on this. Enterprise file was supported, application things, and URL filtering, and all these things you can just see one by one on this one. The next is Meraki SD-WAN. SD-WAN can help your business no matter its size and variety of the deployment options. For lean IT operations, Cisco SD-WAN powered by Meraki is preferred. Lean means like a smaller. If you're not going for a large scale or something like that, you can go for a Meraki. And it is for a full feature in the sense you have to go for sophisticated deployments and all. We'll go for SD-WAN by the Viptela. That is what preferred. So lean IT deploy SD-WAN provided by the Meraki MX Unified Threat Management software, sorry, hardware, and enjoy unified secure SD-WAN for businesses with lean IT teams. And branches and campuses with both the physical and virtual options. You can deploy SD-WAN, Cisco Edge, VEdge Catalyst 8000V, CSR 1000V, Catalyst 8300 series, 1000, 4000 ISRs, and everything is 5000 series and all. Headquarters, data center, and co-location, we can deploy this physical or virtual options by 8500 series switches, ASR 1000 series routers, NFV and Network Hub solutions by the Cloud Services Platform CSP 5000. If you are purchasing these options and hardware or software or something like that, you can able to construct your Meraki. But Meraki is been preferred for smaller organizations. Like if you like to go for a full feature and also sophisticated deployment, you need to go for a Viptela. So this is about Cisco. Then we'll say something about the VMware. VMware is being SD-WAN is being provided by called Velo Cloud. This is number one in the world. Now the current market trend is going on. This is having a lot of shares selling, and they're having a lot of customers are connected to the VMware SD-WAN. VMware NSX, it's called as an NSX SD-WAN by the Velo Cloud. NSX SD-WAN seamlessly integrates the existing service provider network and is a transformational approach for wide area network architectures. NSX SD-WAN enables bandwidth on demand, provides direct and optimal access to the cloud-based applications, simplifies deployment of services, and improves operational automation. Like that, you can just see the diagram on this one. Internet connection is there, MPLS connection is there. On the top, you can just see VLO Cloud SD-WAN authentication, something the automation has been there. So many things are there. We will be seeing that how the VMware NSX can improve our on-premises, only cloud options, or hybrid cloud, something like that. VMware SD-WAN solution of components, SD-WAN gateways, SD-WAN orchestrator, SD-WAN edge. SD-WAN incorporates a distributed network service gateways deployed at the top tier cloud data centers around the world, providing scalability, redundancy, on-demand flexibility. SD-WAN gateways optimize data path, all applications, branches, and data centers. Like that. SD-WAN orchestrator provides centralized enterprise-wide installation, configuration, and real-time monitoring. In addition, like that, we require to have some orchestrator for that. Next, the edge, zero-touch enterprise class application. That's what we can just sell that, send that equipment to the customer place. We can just monitor it from here. We can push all the configurations over here, like that we can do. And there's different type of solutions given by the VMware. Cloud internet only SD-WAN, we can connect it in this way. You can just see it in the right hand side. Enterprise data center is here. This is enterprise data center. This is a SaaS, nothing but a software as a service. And this is an orchestrator, which is this SaaS and enterprise or data center which are connected on the internet. The customer is coming from here, branch side. Branch side with connected with the SD-WAN edge is connected through the multiple connections, either MPLS, lease lines, or through satellite connectivity. That is what dynamic multipath optimization. They connect into the internet. After that, they can go to that either SaaS or the data center somewhere. So this gateway will be forwarding the packet accordingly to the where it should be destined, and this orchestrator will be managing all the edge devices as well. This is a one way of connecting the VMware cloud. Next, this is a hybrid SD-WAN. Hybrid SD-WAN in the sense here the branch side is sitting up and multipath connections are coming. Through the SD-WAN gateways, we will be connecting to the SD-WAN edge or to the SaaS, or the branch can connect through the private MPLS through the VMware SD-WAN edge also. It is possible. So multiple ways we can able to connect it. There is a way of connecting the VMware cloud on this one. Next one, hybrid. This is hybrid means like it is giving the public cloud connectivity also, so SWAS, and it is giving the WAN edge also, and it is giving the WAN controller also, like enterprise cloud. So branch can come in through the internet and connecting to the SWAS, or it can go through the private MPLS through the SD-WAN edge. Like that, we can have many type of solutions can be given to the customer accordingly to his own requirement. Okay, the next bigger thing is like Silver Peak. Silver Peak is in the third place. Many people are buying the Silver Peak SDN, and Silver Peak has given some free access for to train ourselves to understand the Silver Peak communications and all. It's called as a Unity Edge Connect SD-WAN Edge platform. Again, it also the same. Everywhere it just see the same because all universally it's be the same. Edge Connect, Orchestrator, and Boost. Same thing it will be doing. Edge Connect will be like hybrid WAN approach. Orchestrator will be doing all the policy pushing. Unity Boost will be like a WAN managing the WAN properly. And Edge Connect key features are like zero touch provisioning, everyone providing it, virtual WAN overlays, tunnel bonding, dynamic path control that everyone does it, WAN hardening. And WAN hardening is nothing but like encrypting the tunnels with the 256-bit AES technology. Zone based firewall we can configure. Path conditioning it can be possible. First packet IQ means whenever the packet arrives from a branch location, the the edge device which will be identifying this whether the packet need to go to the public cloud or private cloud or branch office or in like something like that. The first packet itself will identify. So there won't be any communication problems as such. The client will be connecting to their own applications seamlessly. That's all. Local internet breakout, granular intelligent traffic can be steering enabled. Routing, supporting all layer 2, layer 3 open source protocols. Cloud intelligence, real-time updates are the best performing path to reach the hundreds of SaaS applications. And this Silver Peak can be, integrated to the Azure as well as it can be integrated to the AWS also. When you are integrating into the Azure, it is called as a VWAN, Azure Virtual WAN, and AWS is called a Transit Gateway Network Manager. Like so, here the branches coming in. This is the Azure cloud. I can just say showing Microsoft Cloud something. So Microsoft global network has been there here. Then it has been connecting to this own switches and it's connecting to the Unity branch. Like this is the connectivity with the VWAN we can able to connect it. And in the AWS global network, it's connecting like this branch. There are three branches over like somewhere Munich and Chicago and Los Angeles. Like Transit Gateway Network Manager. Through this, we will be able to configure the global network. It can talk to the public cloud as well. And it can talk to the Microsoft OC 365 also, RESTful API integrations, continuously learns and discovers the new O365 endpoints and or IP addresses and automatically reconfigures it if new closer 365 point become available. Means if the customer is based out of certain remote locations, it will not be connecting to the corporate office only. It is not required for the people to connect to that. It will be connecting to the nearest location where the O365 service has been mirrored or something like that. We can have it. So that application has been possible in the Silver Peak. Almost everybody is providing the same solutions only, but only the name and the like brand name they just change it and they do it. And how does it works out? Silver Peak. First packet is coming, identifying, classifying, and steer the traffic. Identifying whether it is for a third-party applications like a Salesforce, Workday, Box, and other things. Identifying whether it is for a O365, or it can be going for a homegrown applications, user-defined applications. Continuous data validation, then it goes to the using the best internet link and connecting to the resources whichever they are looking for. So this is like an orchestrator. The screen will be looking like, you can just see this. You can go to this link and you can find out the entire document. I just take these pictures from the document only. So you see that real-time delivery, sorry, real-time overlay and enterprise apps overlay and a default overlay. MPLS, internet, LTE, any connections you can have it on this circuits, and routing and SLA high availability is possible. Topology can be mesh topology, hub and spoke topology, and hub and spoke topology as well. Like and SaaS, cloud internet and application, WebEx connections, Zoom connection. We are doing this meeting through Zoom, and some other connections are there. Here, if you just say enterprise, it's like like overlay. It's nothing but Office 365, Box, Workday, Slack, and many other things are there. Here, when you try to go to the default overlay, the people will go to the Facebook, YouTube, or internet, something like so we can all this. Here, the best control, best secure and local firewall. Everything is available on this for all the services. So overlay defaults will come up here. Firewall zone, something like that. We can configure everything on this. So Silver Peak is providing you all the proper functionalities. That's what it finds out here. First packet. The first packet, whether it has to go to the third party app or O365 or use a different app, accordingly it will forward it. That's the screen here. Application ISPS, something like that. So Edge Connect is using these hardware platforms. Means Silver Peak, when you are buying the Silver Peak, we may have to buy the equipment from them. So they will be providing all this hardware as well as virtual platforms. We need to buy or subscribe to that. Accordingly, we can choose it. So they given the typical environment like deployment where it can go small office, home office, small branch, large branch, head office, data centers, large hub, like that we can go. So when we are going to purchase a Silver Peak SD-WAN, we just need to have all these documents. You need to go through it, and you can call for the sales guy to come up and explain all this. Next, Fortinet. Fortinet is very famous for the firewall. Everyone knows it, but they are providing the secure SD-WAN solutions also. Fortinet secure SD-WAN solution is comprised of multiple components. Overall, the components that make up Fortinet secure SD-WAN solution are FortiGate, FortiManager, FortiAnalyzer, FortiDeploy. FortiGate runs the FortiOS, core of SD-WAN solution, secure SD-WAN solution. FortiManager, orchestration and management. FortiAnalyzer and FortiDeploy. Whole solution come together, delivering a solution that is unmatched by the other vendors like that. So this is how the connection is happening here. Through the MPLS, you will be connecting to the data center, or through the this one broadband, you are connecting to the multi-cloud environment like this. You will be going to this. And the WAN architecture components are discussed here: multi-transport, transport overlay, security services, network and security operations, zero-touch deployment, identity access management, multi-cloud application steering, WAN edge consolidation, and these are all coming under the features. FortiGate, next generation firewall capabilities, what it can do. Everybody is providing the same options. There is no doubt about that. They are all giving the security, end-to-end IPsec connectivity, which we can have it. Everybody is selling their own kind of solutions. We can go for it as which is good for our, like organization, or through the cost wise like that we can just work on. And management control and data planes, how does it been done in a Fortinet? Newly released FortiOS 6.2 adds new capabilities and improves the existing SD-WAN functionality. So management plane is this: orchestration, analyze, and provisioning. Control and data planes are like this: headquarters and data center, internet and MPLS connection, LTE connections can have like this. So this is our client side secure SD-WAN with the IPsec VPN. How does it been given? This is a branch network. This branch network has got a 2 tunnel interface, goes here, and they are connecting to the data centers, FortiGate like that. Then from here, you will be having some data center network like it's been connected on this. Then they will be having the complete connectivity. So normal branch is connecting to the data center, data centers are connected to the outside network. This is about the Fortinet solution for secure SD-WAN. Then one more vendor is called as a FlexiWAN. Is doing it through the open source. That is the only plus point on this. He will also be offering the same solutions as well. Second wave is SD-WAN through the open architecture. SD-WAN open source that allow third-party logic to be integrated in the core of the system. Here the third-party logic is third-party application integrations can be done. Then encrypted channels are there. It will go to the manage and monitoring here. And here the FlexiWAN provider backbone and providers backbone, like branch A and branch B getting connected. B router we can configure. B router means virtual router using the integration API. We'll be configuring this. This is a CPE, means the customer provides this equipment. This is here their architecture is like this: third-party integration possible, domain experts, application service providers, enterprises and users. Three types of integrations to the core system. That is domain experts. FlexiWAN integrates the technology expert companies. VoIP optimization, application identification. Application and service providers. Companies offering SaaS applications, MSPs, service providers, IaaS, like that. And enterprise and users management and all like enterprise complete connectivity is possible on this. And this is a software architecture of your like CWAN. Next one is CloudGenix. CloudGenix is coming from Palo Alto. Everyone knows about the Palo Alto. Palo Alto is very good in the firewall market. So they also come up with their own kind of SD-WAN solution that is nothing but a CloudGenix. So this is again the same. Everything is same. Everyone is providing the same. You just need to choose only the company which is okay for you. CloudGenix provides software-defined wide area network solution from transforms the legacy wide area networks into radically simplified secure application fabric. It's called as the app fabric, virtualizing heterogeneous underlying transport to the unified hybrid like this. You can connect through the LTE, 5G, you can connect through normal internet, you can connect through MPLS to the data center and other SaaS PaaS applications. So here the SDN controller will be sitting, CloudGenix controller will be sitting between the branch office and the connections. Controller, here the devices are called as Eon devices, and there are many models of that. Eon 300, 3000, 7000, 9000, some devices. Again, controller is it is going to centrally occupying all the places and everything, orchestrations, all that. VPN tunnel, zero touch configuration, secure net connections, WAN configuration pushes. Ultimately, everything is same. There is nothing else difference. And deploying analytic, there are two modes there, analytic mode and control mode. In analytic mode, the device which is provided by CloudGenix will be sitting in the path between a branch router and LAN switch. It monitors the traffic but does not apply the policies or make path selection. In this mode, data center side is not required. Next, control mode. The IAN device will be sitting in a path between the branch router and LAN switch and replaces the router at the branch. Okay. It forwards the traffic, selects the best path available, applies security and quality of service policies. In this mode, 7000 in the data center is required if the intent is to enable a VPN connectivity between the branch and data center routers. Like this. So this is how we'll be applying this analytics mode, control mode, and another control mode is with the modem and all we'll be connecting to the MPLS connections. Something like that. I can just go through this all. It's all simple like how they are operating their SD-WAN connections to the Palo Alto devices. There is a new device, the Palo Alto firewall will not work. We have to purchase the ION devices. The ION devices will be supporting the SD-WAN connections for the CloudGenix. The last one is OpenDelight. OpenDelight is nothing but the open SDN controller. We can download the source code and we can work on this. We can configure our own controlling options, and it is very much tunable. And many companies are adopting this OpenDelight, but it is not so famous as such because it is a open source. Because VMware is doing a lot of advertisements, Cisco is doing like a heavy advertisements on that. That's why they are into the market. They are having a lot of quite land share. They are the market on this. But OpenDaylight has also been there in the like limelight. If you are good enough to do some kind of a programming or something like that, you can tune up all the applications on your own without any much help. You can go for a OpenDaylight connection. OpenDaylight is an open source framework for migrating to an SDN network architecture. It has been deployed in data centers, enterprises, carrier networks, supporting broad range of use cases. OpenDaylight provides abstraction, programmability, openness. Everything has been there. Here also there. And it's providing the platform. Why it is providing? Vendor neutral platform, broad support for industry leaders from the operator and vendor community, model driven automation to readily add the support for existing devices through the standard and proprietary management interfaces. SDN support OpenFlow, OVSDB, NetConf, LISP, and other things. Intent-based and outbound API framework for support a broad range of applications. Open ecosystem with a broad set of product and daylight-based network application and services. And it has got its own controllers they are explaining here, like deploying the NFV. NFV means Network Foundation Virtualization, like that. An open platform NFV is an open source project. We can contribute if you are okay, if you are good in programming things. And open NFV is because of vendor neutral platform. We've already seen this. So either you can go for an open source SDN or you can go for a company provided proprietary SDN, SD-WAN connections. So accordingly, we'll be choosing this. This is how the connectivity has been applied. Open NFV, integration, testing features, and continuous integration and continuous deployment, CI/CD documentations are there here. Like so, we can do orchestration management, virtual network functions, KVM, Ceph, Open Delete, Open Central, ONOS, OVS, other things are there. OpenStack has been already been there in the market. Like we are creating our own cloud like that. So in that place, we can use the Open Delete. So this is a data plane acceleration will be happening with this one. And continuity, sorry, that community labs and some other things. So if you are good enough, if you can manage on your own your SD-WAN connections and all without any help of the company provisions or something like that, you can go for the open DLNA connections also. Okay, we come up to the last of the slide. So this is my contact information. You can talk to me on this about SDN connections or something. And if you like to have some courses or something like that, you can come back to me. This is my number. You can note down. And this is my email. And I have some YouTube channel. Definitely, it has been there. So I'm putting all the technological updates, new topics, new technological things, new configurations, labs, scenarios. I used to put it on like the videos over there. You can click on this link and you can get into that. It's possible, and if you like to have any more questions on this one, I can able to answer you now. If you have any questions, you can ask me. You can ask me in the chat also, not a problems. Okay. Do you have any questions? You can ask me. Anyone? Or you can unmute your phone. You can ask any questions to me. That's possible. Okay. Not a problem at all. Hello. Just ask me anything. No problem. Whatever it may be, the basic questions also is okay. I can ask and answer you. No issues at all. People are listening. Hello.
Yeah, listening.
Yeah, okay. Please ask me any questions if you have any.
Hello?
Yeah, please tell me. You can ask me any questions about the technology on SDN, or you can ask me any questions on SD-WAN, like that. I'm looking for a solutions on this one because I just need to prepare some of the things for any one of the SD-WAN solutions, SD-WAN solutions. And VM, why SDN only means I don't understand your questions. Hema, somebody is asking why SDN only means I don't know. How can you describe it? What is your question about? Why SDN only means I don't understand. Please tell me. Can you elaborate your SDN? Why SDN only? That question. You can ask me. Unmute your phone and you can unmute your why we use SDN only? No, no, no. We are not using SDN only in the sense because people are moving towards the SDN. That's what I was telling you on the previous slides also. Already the traditional WAN is already been there. Local LANs are already been there. We are not dismantling them and we are just still continuing with that. But when we try to go for the multiple connectivity because of the traffic pattern has been completely changed. We are not getting into the internet and accessing something. We are not just getting into the other branch office or head office or something like that. There is a traffic pattern has been completely changed. We will be connecting to the branch office. We are connecting to the head office. We'll connect to the internet for searching, and we will be connecting to the public cloud also. And we are connecting to the O365, Salesforce, like many other SaaS platform. Nothing but like a software as a service platform has been offered. So when your packet is leaving that, you may have to do some lot of routing and a lot of configurations are required for you to make that. So that has been completely avoided when you are creating a solution using the SD-WAN connections on this. So every company will be going for SD-WAN connection only in that may taking time because they will have to come with the decisions on that how to go for it or something like. But constructing the SD-WAN is not so easier part because the person has to be a completely the person who are working for at least 7 8 years of experience on the networking industry can only implement the solutions because initial challenges will be always been there to understand the entire topology of this. How does it working? Where the interface goes? Like what all the traffic has been generated on that, and how much bandwidth utilization is going to be for us. Like how can we go for a capacity reservations as well for each and every other application? Like we may have to go for a QoS policies which we already applying. quality of service like. So how do we apply that? Which application requires more bandwidth for that? What kind of a connectivity we may require for to connect to the data centers? Because we are just now connecting to the data centers only. Either data centers or public cloud we are connecting it, but there are multiple traffics need to be generated properly so that we will be understanding that where the traffic need to heading, where the traffic it is, where the traffic is heading means like where it is getting destined or something like that. So accordingly the decision has to be made. So SD-WAN will be a good solution for us. We can go for SD-WAN for this because all the companies are going for SD-WAN only now. So people are earlier they were using everything on premises only, they used to keep it. Then they move slowly to the data center because of the better maintenance and AC power and other things and all centralized. And they from the data centers they move now they are moving towards a cloud because cloud is offering very cheaper rate. Like to keep all the data and other things. And for subscription fee only need to be specified. So given, and the subscription fee can be anytime we can anytime we can disconnect with the subscriptions on this. That's possible. You don't need to own an equipment or something. The same way, SD-WAN is also been now growing. It is also coming up in the market because the solution which is going on, like we are not only connecting to the WAN connections through the cloud connections only. We are doing many other connections as well. So that if any intelligent device has been sit in our own local LAN to understand whether the packet need to go to the SWAS applications or the cloud applications or the branch office connections or headquarters connections or the third party applications which are running on a third party vendor network or something. So if a device can understand that intelligently, then it is be easy for us to route the traffic towards it. And moreover, the entire control of the devices is been completely dismantled. Devices in the sense like a third party like Cisco or Juniper, somebody is giving the equipments and we are paying a lot of money for them to maintain them and all, and for upgradation costs and other things. Those are all getting eliminated because of that. We are programming our own things. We are having the control in our hand. So like a lot of advantages are there when you go to the SD-WAN solutions or something, but it is taking it is not so very much in a full-fledged people are going for an SD-WAN or something, but they are going. It's not like it's been already been implemented last 3-4 years or something. So by the 2025 and all like that, we will be talking about only SD-WANs only. We don't be talking about anything on local LAN or WAN or MPLS or something like that. So I guess I answered your question. Any other questions? You can unmute your microphone and you can ask me questions. You can discuss it with me, no issues. I am ready to give you any answers for you, no problem. Or even you can ask me not normal questions like WAN, LAN connections and all like that. Cost and how long will it take for to learn all these things. Like a general questions you can ask me. Ask me. Hello. Sorry. Yeah, I would like to have it like a more of interactive. Yeah, people are there. I just you can ask me. No questions? I can just show you some of my connectivity which are there. Let me show you one small practical for you. That will also be nice for you. So this is the connectivity which I made it. And this is like an ISP which connections are goes. And I guess everyone can see my screen. This is based on Arista VXLAN. I created some VXLAN for this one. Okay. Arista VXLAN connectivity. This is two routers which are connected to the ISP. They are running an OSP of normal protocol. This is one side branch. This is another side branch. This branch is having two VLANs. One is a VLAN 10. Yes, everyone is connected. Hello. Can you just answer me because there was some problem in the link in between. Okay. Anyway, I will just talk. No problem. It's still recording. I can just stuck on this one. And yeah. So this is the connections which we are having on this, and it's two Arista switches which I configured. One is on one side, one is another one is on a branch side or something like that. We will be connecting the extending the LANs between the one side of the connections or the one side of the WAN and the other side of the WAN. So once I activate on this one, this particular switch, this particular PC can talk to the another VLAN of this. It's possible for that. So this is how the connectivity has been maintained. Yes, the connection is not stable. That's why it is coming up like this. Please wait, let it get started. Then I will be showing you certain practical on this. I will be pinging up from the one side of the LAN to the another side of the LAN. I'll just show you. So it is taking some time. So it's CPU is hitting up like many things, like 88, something like that. It goes on. It will come up. Please don't worry. May take at least 1 or 2 minutes to come up and be ready, so that I can show you that what configuration I have done on the Arista switches and on the Cisco routers on this. See here, I configured the VLAN 10 on this switch and VLAN 20. There are two VLANs are existing. VXLAN, I created the only one VXLAN on this. We've seen that 16 million VXLANs we can create this. I kept the VXLAN as the same number. See that VXLAN 1 and VXLAN 1. On the Arista switch 1 and Arista switch also, I'm keeping the same VXLANs. And here the meetup, we just need to configure with the local loopback IP. That's a 1111 I configured for this. And for the VLAN 20 VTEP configuration loopback, I created it in 333. And in this right hand side Arista switch, I have VLAN 10, VXLAN 1 is configured, VLAN is same. And the loopback, I changed it as 222 for the VLAN 10, 444 for the VLAN 20. VNI numbers we just need to specify, it's an identifier like that. So the VNI numbers has been given 10, 10, 10, 20, 20. Here also the same 10, 10, 20. So what is the idea behind this in the sense? This is one of the data center and this is another data center. These two data centers are connecting towards a ISP connection. ISP connection is nothing but it has been given for a city to city or country to country connections which are going on. So when they are getting connected towards the WAN connection, even though their VLANs are maintained as it is with their own kind of, the VLAN, they are not losing their VLAN content on this. That is what I would like to explain it. So the same VLAN has been spread across the WAN also here. That is the concept of the VXLAN. VXLAN, we can create 16 million VXLAN, we can able to create that. That's not an issue. Here there is a two PCs configured, one on VLAN 10, another one on VLAN 20. On the right hand side, the same thing on the VLAN, one PC on VLAN 10, another PC on VLAN 20 configured. You just see the IP address which is configured on the VLAN 10 is 10.111/24 and this is 10.112/24. Here the VLAN 20 is like 21.111 and this 21.112. When they are connecting through this one, I didn't configure any protocols on this Arista switches. I configured only the OSP on this ISP related ISP routers. Why I'm using the Arista switches over here is like it doesn't take much memory from my PC. You know, if I'm using the Nexus, actually I just need to use the Nexus 9000 on this place. But Nexus will be taking the heavy memory toll so that I could not be able to use that one. So I am using the normal Arista switches. It doesn't take much memory for this. This Arista will be connecting to the another Arista through the WAN connections which are built by the Cisco. This is the normal Cisco device which we are using it. And when I am able to ping from this one to this PC1 to the PC2 or something, I can say that my connectivity has been completely established. Let me start this all the routers to show the ping between the two different connections as well. Please wait for maybe like because it is hitting 100% of the CPU. Arista is taking a time. Maybe if it is getting reduced, I can able to log into that and I can show you all this. It's showing 100% here. It will be reducing because once they are initially starting, it will take a lot of CPU. Later, once it is stabilized, the CPU will be going down so that I can log into the switch and I can show you all the. Now it is reducing 69, 40, 36. Yeah, now it has become 3%. So I can definitely log into this. I'll log into this switch. I'll go to this console. Okay. So this is the Arista login which I made. So configuration is very simple. So this is the interface VXLAN. I just need to make it up. The VLAN 10 I configured. Only one VLAN I configured. Everything is pointing towards the ISP router. You just see here. It's a normal switch only connection. Everything is pointing to the VXLAN connections, and this is connecting here. Like that, I can the same I can show you on this switch also. Console connection. I can go for. It's coming up here. Like, okay. Admin enable show running. So it is here. The same thing like VXLAN 1 is here. Like I just clear up all this. So if I would like to ping between this to this, it should be properly working. It should not be any problems at all. Let me see. 10111. Keep on connecting to that again. PC1 show IP. There's no IP assigned. Let me assign the IP. IP.10.1.1/24. So the IP is assigned. Show IP I can show. On the PC2, let me take the configuration for the PC2. Let me show the PC2. Connect to that. It's not connecting. There's some problem in that. Yes. Stop that. And let me start again. Website is it's having a lot of heavy CPU utilization. That's why it is giving us a problem for this. Let me go back to this. And PC2 is there. Show IP. Definitely the IP is not there, so I will assign it 10.1.1.2/. So when I say show IP, I can just see that ping 10.1.1.1.2. I'm pinging locally. Then I'll be pinging the one. It's coming up. Now I can able to ping from PC2 to PC1. Same I should be able to ping from 10.1.1.2. It's working. Means I can able to go across the VXLAN connections, crossing the ISP boundary, then coming back to the second switch on this. It's on a different city, you can take it as. And this is reaching the switch. So the PC. So this PC you can take it as like in India. This PC maybe like in London or something like that. I'm just using the ISP connections to reach to this one. So these connections are very much possible when we are creating the same VLAN has been configured on both sides. You see. VLANs, but the VTEP configuration and the VXLAN configuration makes sense. How the connectivity is being maintained. This is one of the basic things which we will be talking about the SD-WAN connections as well. I do not want to go much in elaborate because SD-WAN is completely a bigger thing on this one. And so I can go ahead and I can stop all this because my PC may be giving a lot of CPU utilizations and all, creating a lot of issues. So I just like stopped all the connections. Okay, if you have any questions in your mind, you can ask me, and I am very much ready to answer you. And you can give me your, you know, you can give me your email addresses or something, email IDs or phone numbers. You can give me your email IDs and phone numbers on this, so that I can get back to you with all the details on this particular information, which are all. I will share this recording also to you, and you can have this. PPTs also to this. I will be sending all these things to your email address. And I am conducting many other courses as well. I can give you all the informations about the other courses also. You can provide me the email ID only. I will not be disturbing you, don't worry. I will not be calling you or something other asking for any course or something other. Not like an institute or something other. Just a knowledge sharing which I'm trying to use. So You can give me your email IDs or something, so I can send you all the information to you. Hello, anybody? Okay, Harshit Lal has given. Good. Anybody on? Anybody else? You can give it to me. I will give you some more information about the SDN. How do you go for? How do you shape up your career? From where to where you would like to move accordingly? What will be the best path for you to go? Like which SDN you can go for the training or something like that. I can just give you all the information about you. Okay. Anybody else? Anyone else to give some information about that? Okay. Somebody is given. Okay. Thank you. Gobi Manole. Okay. Manuel. Okay. Anyone else? Please give anyone. Everyone. No problem. You will not get any much, like problems and all from the side. So I'll be giving you much information about this to. I'll share it with all the people on this. That's all. Okay. I guess people are having some kind of, let us then we will go ahead and close this meeting. Okay. And because people are, I guess they are silent, they are not asking any questions at all. So thanks for joining today, and very much ready to serve you on any other courses as well. Even SDN or SDN, SDN also, like I'm just going to, start conducting other courses as well on this SDN, maybe later, but not so immediately. I will get back to you on this one by whenever I'm ready with it. Okay. So thanks for joining. I'm closing this meeting. Thank you very much.